This talk is called Quick and Accurate Characterization of Surface Mount Components and Data Acquisition Tools. And essentially this talk is about what can we do to simplify with the characterization things. Hello everybody, my name is Michael Obrecht. I am a Director of Cyber Systems Inc. in Waterloo, Ontario, Canada. A brief introduction. Component characterization is an essential part of any electronics production line. It used to be a tedious and time-consuming job associated with bulky and expensive LCR meters that required complex setup. Luckily, Smart Tweezers LCR Meter has been the first instrument to offer a viable alternative to component characterization since 2004. That device allowed single tweezer touch characterization of those components, even tiny ones. It increased the speed of characterization by an order of magnitude. Since then, the accuracy of multimeters tweezers has increased by at least 10 times. In particular, our latest product, LCR-Reader-MPA, offered by Siborg, provides 0.1% basic accuracy and record-wide measurement ranges from 10 milliohms to 20 megaohms, from 0.1 picofarad to 1 farad, and from 10 nanohenries to 100 henries. Maximum test frequency has also increased more than an order of magnitude, 25 times to 250 kilohertz, which is sufficient to measure even tiny sub 10 nanohenry inductances. The built-in Bluetooth communication allows to easily integrate these devices, LCR meters, into industrial environment by sending test results to a computer in real time and then using it as an instrument for reporting the incoming problems or debugging the process flow. LCR-Reader-MPA won the Best Product of the Year 2020 award according to Plant Engineering magazine. This presentation is a historical overview and introduces the current offerings of LCR meters from Siborg Systems Inc. Siborg Systems Inc. is a Canadian privately owned company. It's involved in the design and production of LCR meters for SMT technology, surface mount technology since 2003. We initiated Smart Tweezers LCR Meter development project in the same year and established Smart Tweezers assembly line in 2005. We created LCR-Reader line of digital multimeters in 2013. The main purpose was to reduce the cost of the devices to make it more affordable, even to hobbyists. We released LCR-Reader Calibri and LCR-Reader-MP in the next years from 2015 to 2018. Eventually, we came up with the LCR-Reader-MPA, LCR-Reader-MPA Bluetooth, and LCR-Reader R2 in 2019 to 2021. In 2019, we established in-house manufacturing facility for LCR-Reader-MPA, and this device won Plant Engineering magazine Product of the Year award in 2020. Our latest product, LCR-Reader R2, has a test frequency of 250 kilohertz and a signature analysis tool that allows to additional flexibility when debugging the PCBs. This picture shows the original prototype, not the very first one, but it's the one of the latest pre-production demo units that was made of a wooden hand curved housing and handmade copper tweezer type probes. The design was based on Atmel 1890S 4433 8-bit microcontroller with 4K kilobytes of programmable flash memory. This is a high performance and low power AVR 8-bit RISC architecture processor. The unit was powered by AA alkaline battery. The photo is courtesy of Alex Bersenev. The first commercial product, Smart Tweezers LCR1, was offered in 2004. The device had a test frequency from 100 to 100 Hz to 10 kHz, with a basic accuracy of 1% for resistance and 5% for capacitance and inductance. It also had an additional two LCR features like AC/DC voltage measurements, diode continuity test, and oscilloscope. Smart Tweezers ST2 was offered in 2007. Pretty much same accuracy, same test frequency range from 10 Hz to 10 kHz, but it had replaceable test leads. The original version ST1 had a hardwired test leads which had to be replaced from time to time due to the gold that's been worn out. This device had a slightly better resistance and capacitance inductance accuracy measurement and additional features, same additional features pretty much, AC/DC voltage, diode continuity test, and oscilloscope. In 2009, a new model was developed that had a same test frequency from 100 to 10 kilohertz, but it had an optional inductive charger with a rechargeable nickel metal hydride battery. Pretty much same accuracy, resistance 1%, capacitance and inductance 3%. Additional features: AC/DC voltage, diode continuity test, oscilloscope. That was the first rechargeable model of Smart Tweezers. A major breakthrough was made in 2011 when a new model of Smart Tweezers was released, namely ST5. It had a better design of the handles. They had shielded two-wire flex PCBs on the handles so that it allowed to improve the accuracy quite a bit. For resistance, it has become 0.2%, and for capacitance and inductance, 0.5%. Also, with this new model was introduced automatic offset subtraction, component sorting, and designated ESR measurement. But at the same time, we abandoned features such as AC/DC voltage measurements and oscilloscope. Currently, the following products are offered by Siborg Systems Inc. Our main bestseller product, LCrreader LCR1, budget LCR meter, and a version of it with adjustable frequency, LCR-Reader Calibre. We also offer Smart Tweezers ST5S. That's a traditional tester for SMT components. Very widely used, very popular. Pretty much any big company has a bunch of them on a production line. Next version was Smart Tweezers ST5S Bluetooth. That's a device that has a Bluetooth connection. The first device that had a Bluetooth connection to the computer so that you can take records on the computer of whatever was done during the measurements and report incoming reports or create other documentation. Pretty much same year, we also started to offer Smart LED test tweezers, which is just a device to well, it's tweezers first of all, but it could be also used as a LED tester. Then we also offered LCR-Reader-MPA. That was a transitional model from LCR-R1 to LCR-MPA. It has many features, but it was kind of bulky, and we eventually ended up with LCR-Reader-MPA later. which the model that won Product of the Year award for 2020 from Plant Engineering magazine. Next model was MPA, LCR-Reader-MPA Bluetooth data acquisition tool based on LCR-Reader-MPA, and that was very popular recently. And the latest product is LCR-Reader-R2, which is the highest available amongst the tweezer meters test frequency of 250 kilohertz, and additional functionality that's called signature analysis tool, useful in some cases. LCR-Reader R1 was first offered in 2013. That was the goal to create this model was to establish a cheaper version that would be available to pretty much a wide market, including hobbyists. Reduced price. We sacrificed the accuracy a little bit. We abandoned a couple of functions that used to be available for ST5S. But at the same time, we reduced the weight and we simplified the interface, so it was just a single push button navigation. The accuracy appeared to be 0.5% for resistance and inductance and capacitance at 1% accuracy. But we also introduced on this device designated ESR measurements. Abundant functions were diode continuity test, automatic offset subtraction, component sorting. Here is the table of specifications of the R1 model. Frequency from 100 Hz to 10 kHz, test signal level 0.45 volts, source impedance 62 ohms, 1 kilo ohm and 16 kilo ohms. Accuracy, as we said, 0.5% for resistance, 1% inductance capacitance, and measurement range from 0.1 ohm to 10 mega ohm, 2 picofarads to 5 millifarads, and from 10 microhenry to 1 henry. That's the most popular device currently, Smart Tweezers Multimeter ST5S. First time offered in 2014. It's a very light model, also like half a weight of the previous ST5, significantly smaller. Same test frequency from 100 Hz to 10 kilohertz. Very good accuracy, same as ST5, 0.2% for resistance, 0.5% inductance and capacitance. Additional features: automatic offset subtraction, component sorting, electrolytic capacitor designated measurement, and DC resistance measurements. So once again, ST5S was the most popular device, very widely used. Automatic and manual LCR meter, measures dissipation factor, quality factor, 0.2% basic accuracy, diode continuity test, test signal from 0.25 per 1 volt VRMS, and Bluetooth enabled model as well. Here's the table showing the ST5S specifications. That's the other offered device, which is a pretty basic device. It does LED test first of all, but it has tweezers that can be connected to any DMM, digital multimeter, and use it as a test tweezers basically to measure capacitance, inductance, voltage, whatever. And at the same time, independently, it could be used for testing LEDs. LCrreader-MPA was quite an advanced device that had many additional functionalities. First of all, it was making LCR and ESR measurements and LED diode measurements as well. A remarkable feature of that device is that it measures ESR in a way it should be measured, like ESR should be measured at 100 kilohertz, and apparently it could not be measured correctly using 10 kilohertz frequency. So if you measure electrolytic capacitance, then we measure capacitance itself, we measure at 120 hertz, which is a typical test frequency for electrolytic cups. And we use 100 kilohertz to measure the ESR. This device had a basic accuracy of 0.1%, allowed AC/DC voltage current measurements, DC resistance measurements, oscilloscope of up to 100 kilohertz, signal generator that generated sine, meander, triangle up to 100 kilohertz. It does component sorting. It also measures frequency. That could be used also for pulse period measurement and duty cycle meter. It had a very high upper limit for the capacitance testing, up to 1 farad. LCR-Reader-MPA is our main product nowadays. This is a device based on LCR-Reader-MPA and has pretty much same functionality. Also, the frequency range is from 100 Hz to 100 kHz. It does LCR, ESR, and LED diode measurements. It has oscilloscope, signal generator, component sorting, AC/DC voltage and current measurements, frequency measurements, pulse period duty cycle meter, 0.1% basic accuracy, and supercap testing and to 1 farads. LCR-Reader-MPA Bluetooth. This is a wonderful MPA model that has a Bluetooth connection to the computer. Therefore, it allows to not just to measure, but also allows to document the measurement results. And even better, it allows to control the device itself, the test conditions from the computer. By setting them, the conditions on a computer according to the value that needs to be measured. So this device is very popular on the production lines and at other places where documentation is really important. Our latest and most powerful in terms of measurement capabilities device, LCR-Reader R2, based on LCR-Reader-MPA, same functionality. It doesn't have voltage current measurements. It doesn't have frequency measurement, but it does have LCR ESR measurements, diode LED. It has a higher, significantly higher test frequency, up to 250 kilohertz. It has dual source resistance, low source resistance, and high source resistance that is important in some cases. And it also has analog signature analysis tool that allows an additional debugging on a PCB or a component. Now we go into the details of the LCR-MPA functionality. Just repeating, it's LCR meter, LED diode measurements, 0.1 basic accuracy, AC/DC voltage current measurements, oscilloscope, signal generator, component sorting, frequency, pulse, duty cycle meter, supercap testing. It has gold-plated twisted probes, backlit LCD display, shielded 2-wire handles, LiPo battery rechargeable, and 4-way joystick for the navigation. This slide shows the functionality of the device and how it's presented on the screen of the device. Going from top left clockwise, it's sound on, sound off, data retention, relative measurement, which is like sorting pretty much, auto selection frequency. In a case if it's fixed frequency, it will be shown here. Shows test frequency. Deviation is the deviation from the specified reference value. It shows auto select, secondary parameter, or parallel circuit or series circuit selection. Then also it shows auto selection of the measurement mode, like RCL and so on. Primary parameter, secondary parameter, could be resistance, quality, or dissipation factor. And the signal level, it could be 1 volt VRMS automatic, which is switching to 100 millivolts in a circuit. Fixed 1 volt VRMS, signal 0.5 VRMS, and signal 0.1 VRMS. This slide shows you the features that the device have. Automatic and manual LCR LED diode, 0.1 basic accuracy, AC/DC voltage and current, oscilloscope voltage waveforms, frequency, pulse duration, duty cycle, sine wave generator, super cup test, automatic and manual test frequency. Frequency is 100, 120, 1 kilo, and 10 kilo and 100 kilo. They are like standard frequencies, and 20, 30, 40, 50, and 60, and 75 should be set up via the menu. Navigating the device has a 4-way joystick. This screen shows the RLCD, resistance, inductance, capacitance, diode mode, which is automatic measurements of those components. Components are identified automatically, and measured values are displayed on a screen. Before every measurement, you have to do open and short calibration by just shorting the test leads and pushing the joystick to the right for 2 beeps. Same thing with the open test leads, thus eliminating the offsets. Main menu. By pressing the navigation button, we enter the main menu, where we can select measurement modes and change system settings. The main menu pretty much provides almost everything that you need to set up when you do the measurements. The joystick functions are different when they are pressed or pushed left or right for 1 or 2 beeps. Depending on that, it could be completely different function. For example, pushing the joystick to the right for 1 beep opens the parameter setting menu. Pushing the joystick up for 1 beep changes the primary impedance type, like R, C, L, and so on. Pushing the joystick to the left for 1 beep changes the frequency. Pushing the joystick down for 1 beep changes the signal level. Pushing the joystick to the right for 2 beeps does open short calibration. Pushing the joystick up for 2 beeps while measuring component initiates relative toroid sorting measurement mode and stores the reference component value and type. Press the joystick down and hold for 2 beeps to cancel relative measurements. Parameter setting menu. The parameter setting menu is opened by pressing the joystick to the right for 1 beep. This menu includes test modes, test frequency, signal level, equivalent circuit, data hold, sounds, etc. Parameter setting menu. The parameter setting menu gives access to select the test parameters: primary impedance type, secondary impedance parameter, test frequency, test signal level, measurement period, serial parallel equivalent circuit, sound setting, electrolytic cap voltage, data hold setting, default to restore to the original test parameters. Primary parameter. Selection of the main impedance parameter, auto. Device will automatically select test best parameter from R as a resistor, C as a capacitor, L as inductor, Z as impedance. Large cap is a special mode for measuring capacitance from 0.5 microfarad to 1 farad. Large cap mode. This mode is activated by using the primary parameter large cap item in the parameter setting menu and has two sub modes: large cap from 0.5 to 40 millifarads and super cap from 40 millifarads to 1 farad. So by manipulating the joystick you can toggle between the two modes, and all the parameters are displayed on the screen. Large cap mode. This mode is for measuring the capacitance or NDSR from 0.5 microfarads to 40 millifarads. This capacitance is measured at 120 Hz, while ESR is measured at 100 kilohertz, according to the industry standards. If we push joystick down for 1 beep, we toggle between the 1 volt VRMS and 0.5 VRMS test signal level. Supercap from 40 millifarads to 1 farad. Again, we can toggle the modes between the supercap and just large cap. Secondary impedance parameter could be automatic, resistance, quality, or loss tangent. Test frequency settings. You may do it by pushing the joystick to the left for 1 beep. It'll go through 100, 120 Hertz, 1 kilohertz, 10 kilohertz, at 100 kilohertz. For additional frequencies 20, 30, 40, 50, 60, and 75, you should go to the menu and set the frequency there. RGC plus LED mode. This mode is for testing DC resistance, leakage currents, and parameters for LEDs and diodes. The important feature of this particular mode is ability to set up a shunt resistor on a board that can be used later for evaluation of the current flowing across this particular shunt resistor. It's just a recalculation of the voltage apparently, but it's very useful. You don't need to recalculate on a piece of paper, you just get it done on a screen of your device. LED mode applies a 3.5 volts voltage pulses with alternating polarity, so that it determines the forward voltage drop and reverse current. The diode mode is used to test diodes using DC bias, recommended for in-circuit characterization of PN junctions. The screen displays the voltage drop in open state and when the forward bias is applied. DC resistor tests. Again, it's just very good for in-circuit measurements because it apparently doesn't involve capacitors and PN junctions if the voltage is low enough. And also can be used for measuring the shunt resistor that could be used for current measurements. AC-DC voltage mode measures AC-DC voltage. It shows the VRMS, which is the AC component, and it shows also the actual voltage. It could be used also for capturing the instantaneous values of maximum and minimum voltage on a component. AC-DC current mode allows you to measure the current through the previously set shunt resistor. Very useful function, oscilloscope mode allows you to show voltage waveforms at any PCB node for a live circuit. Apparently, if you don't use that special connector, that's been developed by us. It would be difficult. You can only measure one component, but with this Kelvin probe connector, you can actually use it at any point, at any node of the PCB. Oscilloscope mode shows you the waveform, and you can adjust the time scale and voltage scale by using a joystick. Frequency meter mode, it can measure frequency, period, pulse duration, duty cycle, and counts. Frequency meter mode shows you frequency, period, counter, duty cycle, and pulse duration modes, sub-modes. And note that the functionality of a joystick for different sub-modes are different. Signal generator mode. Basically, it just generates a sine wave, and you can use your joystick to change the frequency or change the amplitude of a signal. This is a summary of specifications. So 100 kilohertz, 100 hertz to 100 kilohertz, signal from 1 to 0.1, source impedance 100 ohms, resistance, capacitance, and inductance 0.2 to 0.5, typical accuracy. Basic accuracy is 0.1%. Continuity and diode, parasitic offset subtraction, lithium-ion battery with micro USB charger, backlit LCD display, 0.35 weight, joystick navigation. Very wide measurement ranges, from 10 milliohm to 20 megohm, from 0.1 picofarad to 1 farad, from 10 nanohenry to 100 henries. Additionally, it does LCDC voltage measurement, LCDC current measurements, automatic test signal reduction, 2.1 volt for in-circuit measurements, oscilloscope transient voltage for up to 100 kilohertz, signal generator, and large and super large capacitance testing. LCR-Reader-MPA Bluetooth. This is a data acquisition tool. Basically, the main difference is that all the results that you see on a screen can be sent to the computer by simply pressing the space bar. And thus you create the document on a computer that you could use for any future work. This slide shows you how the interface with the computer looks like. It's called LCR-MPA Bluetooth Logger, and on the screen you see this main section of the screen with the parameters encircled in red. They are clickable, so when you click on those parameters you see the little menu that allows you to actually change the test parameters, and then it'll be used when you do the measurements on your device. The main feature is also be able to grant a pass or fail upon testing. You set a profile of a component, a specific set of parameters, so use there like a component type, and then secondary parameter, like for example, a serial resistance for the capacitance or inductance. And then when you do the measurement, the program actually can see if the measurement actually fits the specification of the component. You also specify the tolerance that's acceptable, and it shows you in green if it does fit into the tolerance range, or it shown by red if it doesn't. For a single component test, you basically just measure the component once you define it, and then if you press the space bar, it gives you the component measurements and saves it in a spreadsheet. When you specify single component, you select single component, define reference values, and press on write to write them. Then when you press the space bar, you record the measurement into the spreadsheet again. For a multiple component test mode, you specify a number of components in your spreadsheet, and then you select one of them for the test, and then you click the spacebar to measure, and then you see if your test column is green, then it's a pass, and if it's red, then it's fail. The latest and the most advanced in terms of limits is the model LCR-Reader-R2, which is based on the same LCR-Reader-MPA. Again, it does LCR-ESR measurements, but with a higher limit on a frequency, 250 kilohertz instead of 100. It has dual source resistances, analog signature analysis tool, signal generator, and LED diode test. Signature analysis tool. This slide shows you how different pictures represent different components. Like, for example, on the picture on the right, you can see a capacitor which is almost ideal circle. That means that it's almost ideal capacitor, very, very small parasitic resistance. Next one is inductor, which is okay inductor. I mean, not perfect inductor, but it's okay inductor. Next one, second row left, is a inductor that's a little worse than the first one, and the next one is even worse. The third row left is a diode. It looks like a right angle rather, and the right one at the bottom is the actual resistor. Specification for R2, 100 Hz to 150 kilohertz, 100 ohm resistance, impedance, resistance 0.2, inductance 0.5. We also currently offer some accessories that are very useful when we use LCR-Reader as a meter. Capacitance offset calibration board, LCR-Reader, Smart Tweezers Kelvin probe connector, LCR-Reader-MPA ring gold tester, and variety of spare gold-plated test leads. Offset calibration board is the most important accessory. It allows you to accurately eliminate the parasitic capacitance of the test leads, because it depends on the distance between them. You have to specify a specific distance, so that board has holes corresponding to the specific sizes of the components. Kelvin probe connector is a shielded 2-wire connector that connects perfectly onto the signal lines of the LCR reader or smart tweezers, and therefore it gives you rather low parasitics involved when you do the measurements. You could use it to measure impedances on any board, on any location of the board, or the waveforms if you use a oscilloscope function. LCR-Reader coil ring tester. That one shows the quality of the coil, and it detects if the coil has a short turn around it or within it. This particular slide shows you how the short turn affects the response of the coil tester. You can see that it changes from 8 to 2 oscillations when you introduce the short turn. And here is a picture comparing the two different situations: no short turn and short turn. LCR-Reader-MPA and other digital tweezer meters are available from LCR Online Store DigiKey. Amazon Marketplace in USA, Canada, Europe, and Japan. Regional resellers are available in USA, India, China, Japan, and the United EU.